All right, welcome back, everyone. It is with great pleasure we would like to invite Dr. Bijan for the keynote speech in the event today. We very much appreciate her time, and Dr. Bijan is a Lockheed Martin Fellow and has worked on numerous aeronautics and space programs, including F-35 and space-based infrared systems. Dr. Bijan is a certified enterprise architect, certified systems engineering professional, and she holds several other amazing certifications and industry expertise. Dr. Bijan was the president of North Texas Incorsi chapter for 2 years, and she is now the corporate advisory board representative for Lockheed Martin. Dr. Bijan, thank you very much for accepting our invitation today and agreeing to share your insights on the use of model-based systems engineering to perform functional analysis to analyze customer requirements. The floor is all yours.
Hi, I'm Yvonne Bijan, and I'd like to thank you all for inviting me here. I'm pretty excited. I'm going to share out my screen. That's an airplane that you can hear flying over my house. All right, do you see my screen all right?
Yes, we do.
Okay. So today I thought I would talk about using model-based system engineering to go through functional analysis of a customer requirement that we've gotten on one of our programs. This is the abstract and bio that you've already seen. One of the visions of system engineering, by the way, is to meet our customers' need by applying systems engineering to deliver high quality systems. How many of you know what system engineering is? You can use the yes, no buttons in your participant window if you like. All right, so I have the NCOSE and ISO 15288 definition here. It's an interdisciplinary approach governing the total technical and managerial efforts required to transform stakeholder needs, expectations, and constraints into a solution, and also to support that solution throughout its entire life. So all that really means is that we're taking what the customer needs. They have some sort of problem, they want it fixed, and we try to find a solution for them that they can operate and maintain throughout its useful life. System engineering is not an organization or a tool. It is meant to be applied across programs rigorously, and it is basically the technical glue that makes all the other separate design disciplines fit together so that they function as a whole system. So the systems, they are interacting or independent components that form an integrated whole, and all systems have a structure made up of parts, behavior where they provide a desired function for their users, and relationships that talk about the interfaces across the parts and the external environment. And these relationships could be data that has to get transmitted, it could be power, it could be electrical signals, it can be physical structural supports that you have to have. And the images here are examples of systems, starting with an extremely simple one here of just 2 parts, and going on to having a more complicated system here of maintaining a fighter jet so that it can be operational. So there's inventory systems here, there's repair systems, and all that has to be managed as well. Here's the system engineering V, for those of you that haven't seen it before. And it starts up here with understanding the user requirements and developing the system concept. It also includes planning out how you're going to validate that you've given the right system to your customer and that you're actually meeting their needs. And you go on to develop your system requirements, and you start thinking about how you're going to do your verification once you have your system. And then you break that down into your subsystems and your configuration items. You evolve your build to specifications. And then you go and write the code, or you build your parts, or maybe you go and buy the parts from somebody else that's already made them. You inspect the individual parts and you put them together and you make sure the assembly works, and you keep integrating them. You don't want to wait all the way into the end to test it, because if it doesn't work, then you're going to have to go disassemble it again back to wherever it was broken. So we do this iterative integration and testing. The time is along the x-axis, and this is drawn kind of fat for a reason. It's so that whenever you take a vertical slice of time through here, you are hitting more than one of these boxes. And that's because it's an iterative process with the pieces of them interacting with each other. As you work on the activities in here, you may go back and update things here. And so you usually iterate through here. And so at any point in time, you're actually working in more than one phase at a time. This is out of the NCOSE System Engineering Handbook. They break up a lot of the system engineering processes into 4 groups, and each one of these talks about steps and inputs and outputs that you need in order to accomplish system engineering. Most of us are familiar with the technical processes, and we spend most of our time working on the activities within these process groups. Down here we have the Department of Defense life cycle. And it has material solutions, technology development. You go and build it, build out your design. You start building something like a ship or a fighter jet, and then you operate it and maintain it over time. Now, all of that looked pretty linear, right? Very simple, step by step. You do this, you do this, you do this. In reality, it's not really that simple. And this is a life cycle from the Integrated Defense Acquisition and Technology from a few years back, where they tried to capture how it really works for them. And you see that it's a lot of parallel processing going around. There's loops going backwards. They're going through the V multiple times throughout the material solutions, the technology development. And this is kind of a mess, isn't it? And so the reality is, we're doing multiple things at the same time. We're iterating, we're going back and forth. So I have this quote for you. In theory, there's no difference between theory and practice. In practice, there is. So the theory here is that top-down system engineering process says that requirements start at the very top level system and we decompose them into lower level systems. That's the way it's supposed to work. Requirements are clear, they're singular, they have shell statements for U.S. contracts. I think a lot of you might have taken a system engineering class at UTEP and you heard all these rules, okay? But what really happens is we'll have a customer give us a requirement like the one here. The vehicle should apply engine health monitoring and engine system integrity program for engine maintenance. That's what they give us. This isn't a top-level requirement. It's not singular. It's not exactly clear. We have a lot of questions about this. So what are we supposed to do with it? A lot of people will take this requirement and they will insert it into whatever tier level spec they think it fits into. This doesn't fit into the top-level spec. It fits into this tier down here. They'll throw it in there and they'll start working on it. But what happens when you get a lower level requirement like this, where they're being maybe a little too detailed, you also get requirements that are missing that they didn't think about when they would have if they started at the top level. So we're going to try to work our way backwards from this. So we look at this requirement and we think about what's wrong with it. I have some things here highlighted. The vehicle should, there's applying, there's monitoring, there's some sort of maintenance, there's an and statement. So I have should instead of shall. I've got the vehicle instead of the top level system. I've got an and in here, which is immediately a red flag about it not being a singular requirement. It talks about the purpose being for maintenance. And so I've actually got a few problems here. And so I started thinking about what do I really need? And a couple of things that I noticed right off the bat is that some of these requirements aren't even for my system. They're for my company. My company, the Acme company, has to define an engine and system integrity plan and measure some things. And the Acme company has to implement that plan. And so I've got a couple of business requirements here, and it's not quite complete, but I've begun to derive them out of here. And I have a rationale that I document in my model for why I've done that. Because the original requirement up here stated I need to apply the plan, that means that the company's going to need to develop that plan. And if we don't write this down explicitly, somebody will not write it. Or maybe, you know what, maybe the company isn't supposed to write this plan. Maybe the customer intends to write it and tell the company to follow it. When we write it down and we make it explicit, this opens up that conversation to say, oh, yes, you do need to do that. These are the things we want measured. These are the things that, how often we want to measure them. And so we'll refine this as the program goes along. If we're required to implement the plan, a lot of times people want evidence. They want some sort of proof that you actually did implement the plan. And so we have a question here about, do we actually need to show the customer proof that we have to follow the plan? And so I've got a problem statement right here so that I have it as a reminder later when I have a chance to talk to the customer to follow up with them and ask them, do I need to work on this? Do you want some sort of evidence that we're actually following the plan? So I have these two requirements now, and I'm going to start working on the ones I think are about my system. So I have my original requirement up here that we're going to keep working on, and we're going to work on what the vehicle should have to do. So if a vehicle system has to monitor the engine status for maintenance, we know that you have a function right off the bat that the vehicle has to monitor the engine. Now, what should I do next? If I'm monitoring the engine and we know the purpose is for maintenance, you can start thinking your way through this. And it doesn't even matter now if I have a car or I have a boat or it's if it's my personal car or I'm doing a fighter jet for Lockheed Martin, there's still going to be a logical flow of steps here that happens, and we can think our way through it. And so I think that if I'm monitoring the engine, this is some raw data that's going to come out, like maybe RPMs and temperature and stuff. I'm going to have to collect that data and maybe put it together in something that I can actually use later on to figure out if I need to do maintenance or not. So I'm going to collect that data and I'm going to store it. And I'm also going to have to report it to somebody so that they can figure out if maintenance has to be done. And so these are the functions that I believe the vehicle system has to do. And so I keep going from there. Now what do I need to do? Well, like I said, somebody has to figure out if maintenance needs to be done. And so I have a logistics system up here that has to receive that data, because if the vehicle's reporting it, there has to be somebody on the other end of it that's getting it. So the logistics system is receiving the data. Now this might be the repair shop for your car. Maybe you take your car down to Pep Boys or you take it from Meineke, right? And they've got this little portable device that they go in and they plug into your car, and your car gives them some code number. All right, and so that might be a physical implementation of this on a real system. Well, after they get that code, they have to analyze it. What does that mean? And they have to figure out what the corrective action is. And so they might get a code that says there's something wrong with your transmission. And then they go and they do their troubleshooting, and they have to figure out, what does it take to fix your car now? All right. All right, so then after the logistics system figures out what it takes to fix your car, there might be a maintenance order that goes to the person that's actually going to go fix your car. Now, maybe they have a tablet in front of them and they get an alert on that tablet that says, go fix that car that's over there. This is what's wrong with it, and this is what you got to go do. Maybe there's just a board up on the wall, and they put the name on the wall and what the work order is. But somehow the logistics system now has to tell the person that's actually going to go and fix your car what to do. So the maintainer fixes your car, and hopefully it's actually fixed, but whether it's fixed or not, you want to know the results, right? Think about when you take your car to the repair shop. You're sitting there for hours in the waiting room, and then the maintainer comes out there, and what do you want to know from that maintainer? You want to know if it was fixed or not, right? That you can now go off and drive your car around town. It's no different for any of our complex systems either, like our fighter jets and stuff. If somebody performs maintenance on our system, we want to know that it's actually fixed. Or if it's not fixed, what the problem still is, so you can figure out where to go from there. And then the results of the corrective action, they are stored, and the results of the actual fix or what's left over to be fixed are stored, right? For your personal car, you might keep a little logbook in your glove box where you say on a certain date that something was done to your car. For a fighter jet, we've got a computer system that keeps track of everything that's ever been done to the jet and when it happened, and if it's operational after repair took place. Right, so regardless of how you do it, you generally want to keep a record of everything that's been done. So we've decided for this example, the logistics system is the one responsible for that. All right, so taking a look at this, I think my overall goal here is to maintain the engine. When I look at all these functions here and I try to bring it up a level about what is my system supposed to do? I've got a vehicle, I've got a logistics, I've got a maintainer. What is the overall functionality I'm trying to achieve? And the purpose here is to actually maintain my engine and keep it running so I can operate my car, or I can take my boat out on a trip and stuff. So this is the purpose of the overall system. Now that I have the purpose of the system for maintaining the engine, I can work on decomposing this. This is just one flow. I might need other flows. And so now I'm going to need a system requirement that is really about maintaining the engine, and the vehicle is going to need requirements about monitoring the engine and collecting the status. The logistics system is going to need requirements about getting that status and processing it and analyzing it and determining the corrective action. And so this one little requirement up here that the customer has given us, it's turned into 2 business requirements and a whole long list of subsystem requirements that we've gotten. So I started thinking about this, and here's my system requirement. The system has to maintain the engine, and I map it to this activity. And this is part of my rationale of why I created this requirement. And I say the system has to maintain the engine in accordance with that plan that we were supposed to write. And I put in the document number to help people find it and what version that I am going to comply with, because things change over time and I need to keep track of which one I'm actually complying with. Then I keep going and I take a look at the vehicle now, and I have all these functions underneath the vehicle, and I start writing requirements for those. And I say, okay, I had a requirement to monitor the engine, right? So what does that say? And I think it says the vehicle shall monitor the engine status from the time you start the engine to the time you shut it down. Basically, I'm saying all the time it's running, right? That's what you want, right? On your car, you turn your key and the car starts up, and you want it to start monitoring the status. It starts collecting the status, and it does it in accordance with this document here that basically is going to define what all has to collect, because that was too long of a list to put here, so I'm referencing another document. And I want it to collect data every 30 seconds. That's what I think. And you might all argue with me that I don't need it to be 30 seconds, I need it to be every minute, and we can refine this number later on. But I do know I need to collect that data. I know I need to store it. And so the vehicle will store that information for at least TBD hours. And now I don't know what TBD is, but I'm going to have to figure it out. And a lot of companies will have a TBD burn plan where they put together a plan on how are you going to figure this out. And so TBD is probably going to be the longest amount of time that it might be before you took it into repair. So if you were thinking about your car that you're driving around, if it was storing engine data in the car and you wanted to store it, it could be years before you take it into a repair shop and pull that data. And so that's going to drive a lot of requirements on how much storage capacity there has to be in a car. If we're talking about a fighter jet or something that is going to fly around for hours on a mission and then it's going to come back to its base and land, maybe we only need enough storage for that one mission because it's going to come back to the base and we can pull the data off the aircraft and store it somewhere else. And so regardless, we're going to have to do some analysis here and figure out what that TBD is. To report the engine data, we know there's going to have to be interface control data that talks about how we transmit that data from the vehicle to the logistics system, how long it could take to transmit that data. If I had a jet that was flying around for hours, or I had a helicopter flying around with hours, that could be a lot of data to collect. And if my car is collecting data for years in between going to the repair shop, that could be a lot of data to collect. How long is it acceptable to wait for your car to report that data to the logistics system? And you can think about when you're sitting in the repair shop, right? How long are you willing to wait for the maintainer to come into the waiting room and say, hey, this is what I think is wrong with your car. You want to wait minutes? Is that okay? Hours? Days? Right? So think about what's acceptable in here to fill out the TBD. So we keep going. So now this one, we're working on what the logistics system needs. And so here are all the activities that I had defined in the logistics swim lane on the previous slide. And I start working on what I think the requirement statements are for those things. And then I could tell the logistics system, these are all the things that you have to do, right? And you'll see that I still have a few TBDs in here that I have to work on because we don't get everything perfect on the first iteration, right? I'm just drafting these things up and maybe I need to go talk to a subject matter expert in logistics or repair services to find out what's reasonable here, what's feasible here. Maybe I still have some questions for the customer about what they expect in terms of how long to wait. And so I've got a few problem statements down here that I have linked to the requirement. So as I've gone, I have kept track of the traceability from my logistics requirement to my system requirement back up to my original customer statement. I'm keeping track of problems that I have because I haven't completed the analysis yet or I still have questions. And I'm keeping track of why I defined this requirement in the first place. And so now I have the logistics system is receiving the engine status data in accordance with interface control data that is documented somewhere. We haven't actually written that yet, so I can't populate it. And I have the logistics system shall determine the corrective action to do in response to a diagnostic analysis report, which, if you remember from the activity diagram that I showed, that there was an analysis done. So that's kind of implying that a report is going to be generated or some sort of results out of that somebody's going to use to determine the action to take. After the maintainer did the corrective action, they're going to receive that corrective action, again, in accordance with some interface control data, and they're going to store it. And then you want to think about how long do you want to store that information for? For my own personal car, I store that information for as long as I have the car. And I used that information one time because my car broke down and we went out and we got it fixed. And then the car broke down again, we went out and got it fixed. The car broke down again, we went out and got it fixed. And I looked at my log like, you know, I just fixed that exact same problem 9 months ago. And my log file was also showing me that the time in between the breakdowns was decreasing, and I was fixing my car more and more often. This wasn't something in my imagination. I had a record showing that I was fixing my car more and more often. It kind of made me think I wanted to buy a new car because I'm spending a lot of time fixing the old one. And so there's a lot of reasons why you might want to keep this log file around. It helps you make decisions later on. It could help you figure out that there's a specific part that keeps breaking frequently, or maybe you want to go figure out why that one part keeps breaking all the time and see if there's something you can do about it. I added in requirements for analyzing the data and how long it can take to analyze that data. Again, there's some sort of reasonable time frame where you want somebody to get back, and this might vary depending on whether or not we're talking about the time it takes to analyze what's wrong with your phone, your car, a jet, a helicopter, or a ship, right? So this number down here might vary, but there's some sort of reasonable expectation of how long you can take. Normally weeks is not acceptable. And then again, we have to store those results as well. So the vehicle and the logistics requirements need to be decomposed to the vehicle and logistics subsystems and the subsystems below that. And so we might pick on a function to say, what exactly is involved in the vehicle monitoring this engine? And I'll make a new diagram that is a child to the one I just looked at. And I started thinking about what does it take to actually monitor an engine. And I know from the previous one, this is the parent here, that my output is supposed to be engine data. So now I have to think about what do I need in here to produce engine data. And I believe that I have a propulsion system in my vehicle, and there's some sort of monitoring system in my vehicle. And now I need to think about what functions need to happen in order to produce this information that I'm going to use in the rest of my system. And so I start thinking, well, I want to measure RPMs, and I want to measure temperature. And then I'm thinking, there's probably some other ones, but I'm not smart enough to know what they are. So I put a problem statement here to basically remind me that I need to go find somebody that can help me figure out what else goes in here. And so the propulsion system is going to need to do all these measurements. It's going to pass that raw data to the monitoring system, which is going to be the thing that collects and compiles that data into engine data to pass it on to the next step. So hopefully this makes sense so far. I keep doing this until I have enough information to provide it to a supplier in order to build the part for me, or until I have enough information to buy a part. Is there a propulsion system out there in the market already that I can buy that does all these things for me and provides this information? Is there a vehicle out there in the market already that does all of this for me that I can just go buy? Or do I need to tell my hardware engineers to develop some sensors for me that I'm going to put in my system, and some software engineers to take the data coming out of those sensors and do something with it, right? And so you keep adding enough level of detail until you have enough to hand off to the people downstream of you, and until you have enough to make that decision about, are you going to stop here and go build something or buy something, or do you need more information? So this will help you know when you should stop, when you have enough information, because you can keep adding stuff and adding stuff and adding stuff here forever and never finish. And so I use this as a guideline to help figure out when I have enough. As I worked, you notice in some of the charts that I was adding the problem statements. And so what I like to do in my models is basically create a table that lists out all my problem statements and what thing that they're attached to. And so here are a bunch of problem statements that I wrote as we worked, and what model element I attached them to. This is the one on the activity diagram, and I forgot to attach it to something, so maybe I want to go back and do that. But now I have a consolidated list of things that I know I have an issue with. And maybe some of them require that I need to talk to my customer so that in my next customer technical exchange meeting, I have a list and I can start going through the list and say, hey, do you want us, Mr. Customer, to provide you some evidence? What do you think some of the TBDs here should be and how long things take? And this is my list for maybe going to some subject matter experts. What else do you think I need in here for collecting data? And so this is in the model data, and it's associated with everything, so I can keep track. And as I get the answers to these questions, I can go back into these elements and start fixing them with the answers that I've discovered. I also kept track of which systems satisfy a requirement. So as I went through and I said this requirement was for the system to do, and this requirement was for the vehicle to do, I drew traceability relationships to say that the system satisfies, maintain the engine, the vehicle maintains it. And what I could do is I can generate a table, because a lot of times our customers go, hey, how do I know you're really satisfying that requirement that you wrote? What does that, right? You could pull out the table. And the nice thing here is it's all integrated in this model. I didn't populate anything in this table. This is just a view of the data that I had already put in the other diagrams as I worked. So I made a requirements diagram, I put these requirements in here, I defined my system structure, and I linked the system elements to my requirements. And then I just generate this view to give to the customer and say, hey, these are the things that we're going to build for you in order to meet these requirements. And they can take a look at the requirements, and they can take a look at this, and they can give their approval, or they can give us feedback on what they would prefer us to do instead. Maybe you'll come in and say, you know what, no, you're not doing that. We're going to do that, and we're going to tell you what that ICD is. And so this is another view of our data and something that we can use to have a conversation with our customer. All right. This is just another one. This is a quick and easy view to see how my requirements map to my system in a matrix format. This is also automatically created from the data that I'd already put elsewhere in the model, but I can take a look at this and I can see if I have any holes. And what I see here is I have not done anything yet to address those two business requirements that I defined at the beginning. I defined those requirements, and then I moved on to monitor the engine, if you recall. And I never actually went back and addressed these two requirements. And so I have nothing here that satisfies them. This is a gap, right? If I don't define something to satisfy them, then when I go off and I build my system and I give it to the customer, they're going to be like, what is this? You know, where's your plan? How are you implementing it and stuff? So I have a problem here. And this is a pretty quick, easy way to see it, because I can see a count of all the requirements here and all the systems, and there's nothing here. There's also nothing here. And so this indicates one of a couple of possible problems. If this mission systems, whatever that is, doesn't have any requirements to satisfy, I have to ask myself a couple of things. One is, do I need a mission systems? Okay. Or did I not write any requirements for the mission systems? Maybe I still have some work to go do. So this is either I need to delete this, or I need to add some additional requirements that go to the mission systems. And I'm thinking, I do need a mission systems. I need to add requirements to it. And so that's representing work that I haven't done yet. And so I can also use this to check my progress and see how much work I have left to do. And you see, I've got that problem in a couple of places. My propulsion system doesn't have any requirements. My monitoring system doesn't have any requirements. If I wanted to hand this off to a supplier to go do for me, I'm not ready for that yet. And so this is just a quick and dirty view of work that I have left to do, problems that I might still have to address. All right. As I worked on my model, I'm going to go back to one of the activity diagrams. As I worked on the model, whenever I put an activity inside one of these swim lanes, that activity got assigned to this system. And so instead of going through every single one of these activity diagrams, and on one of our real programs, I might have 300 of these, I might have 1,000 of these, instead of going through every single one of these to see if all my systems are doing something or all my systems are all my activities are in a swim lane, what I can do is have one of our modeling tools generate this table for me. And so I have my allocations table here with my system elements again, and these are all the activities that I have defined so far. And what I see is that all the activities that I defined have been allocated to a system element. So I'm good there, right? But I see this mission systems thing coming up again. And now I've got this mission systems thing, it doesn't have any functions. On the previous slide, it didn't have any requirements. So again, why do I have this mission systems if it's not supposed to do anything and if it doesn't have any requirements? Maybe I should get rid of it. Or maybe I need to go talk to the mission systems team and say, hey, how come you're not putting this stuff in here? Right? So it indicates that I have unfinished work, or I've got some sort of problem. And a team is going to be assigned to work on each one of these things. And if you don't have somebody assigned to work on it, nobody works on it. So that's one of the reasons why you want to make sure all the functions are assigned to a system. Because if you are the person that's assigned to work on propulsion, you're going to pull up your propulsion document or your propulsion model, and you're going to go look at it and go, oh, I'm supposed to do this and I'm supposed to do that. You'll look at your requirements. These are the requirements I have to satisfy, and you'll go off and do your work. If something isn't mapped to anything, no one will take a look at it. This is a case where it's actually better to have something that's incorrect than to have it missing altogether. Because if this one didn't really belong under logistics and you assign it to logistics, then when the team gets started working on that, they're going to complain. They're going to say, hey, that's not mine. And then you'll have a discussion with everybody about who does it really belong to, and maybe you say, you know what, I've done my analysis, it is yours, you're doing it, right? Or maybe you say, oh, well, you're right, that one would have been better over here under vehicle, and you go update your model to say it's the vehicle responsible for doing it. But we want to make sure there aren't any gaps in here, and we want to make sure this mapping makes sense. Does it make sense for the logistics system to be the one that analyzes the data? Maybe it makes more sense for the vehicle to do it. Maybe there's a system on your vehicle that's analyzing the engine status data, because I know some of you have cars with a dashboard that says what the status of your engine is. It's giving you real-time status, and you don't require some repair shop and person with a little handheld device plugging it in to tell you that. And so if you end up writing a requirement somewhere or have a customer tell you that's part of what they want, then you might adjust this allocation to be over here, which means you would go back to the activity diagram and take that activity and move it over into the swim lane that's for the vehicle system. One of the things I get from adding those traceability relationships as we went along, if you remember the requirements diagram, and I had all those trace relationships, I have all these satisfies relationships, I have all these allocate relationships, why would I want to spend the time putting all those relationships in there? It's not as easy as just drawing the line in a modeling tool and saying I have it. I actually have to do some analysis to say what the right relationship is before I draw that line. So why would anybody want to take the time to do that? It's tedious, and a lot of people don't want to do it. Well, one of the things I can get out of a tool if I do it is a view that shows me all the relationships. So let's say I had this requirement from the customer, and I had one of those technical exchange meetings with my customer, and I asked them some of my questions, and I showed them what I had, and they said, no. You got this requirement right here all wrong. That's not what we wanted at all. I can see what's going to be impacted by it. So I would go, okay, this requirement they said is all wrong, and they want something different there. So I expand that, and I see, oh, these are all the requirements that go back to this one that might be affected by the customer wanting something different. And so I take a look at these and I go, okay, the change they wanted here, does it affect this? Does it affect this? Does it affect this? Well, if it affects the analyzed engine data, then I take a look at it and go, oh, well, that was assigned to the logistics system. And so I need a logistics team to go see if any of the functions are affected by that change. And so they'll go and look, okay, so the logistics is responsible for these functions for that requirement. And you know what, this function right here, this behavior, it was affected and I have to go change it. So being able to draw these relationship maps and follow that traceability can help me figure it out. And it works the other way around too. You've done all this allocation and assignments and stuff, and the logistics team they're working on this and they're trying to satisfy the requirement, and they figure out that well, they can't meet the requirement the way you wrote it. Maybe you said it had to be done within 50 minutes and it's going to take 2 hours to do instead of 50 minutes. And so they come back and they tell you, you know what, the technology's not there. We just can't do this with the current transmission rates that we have. And so you might have to go back and trace your way backwards to see what else is related to that and make adjustments there. So maybe you have to update the requirement. And if this requirement is going to take twice as long to do as you thought, maybe there's something else somewhere else in the system where you can shrink it down so the total time is still enough to make the customer happy. Or maybe you can't. This helps you figure out what you have to go analyze. And then if you can take the adjustment out of here and put it somewhere else, you're good to go. If you can't, you're going to have to go back to the customer and have another conversation with them about not being able to meet that requirement and find out if they're willing to adjust it a little bit, or are you going to have to develop some new technology that's going to let you transmit data faster to get us through? And you say, you know what, we probably could do that. We'll develop you a brand new transmission method that is super fast and has more bandwidth that'll enable us to do that. And it's going to cost this amount of money, and it's going to take us 2 years to do that. And the customer will decide, well, you know what, I don't really want to pay $1 million for that. 2 hours is okay. I'd rather take it 2 hours than pay $1 million for it. Or maybe they'll say, I really, really want it to be 50 minutes. I'll pay you the $1 million to get it done, right? And so having all these relationships in place will help me keep track of that and figure out what I need to adjust. As I worked on decomposing my activity diagrams, the modeling tools, they keep track of those relationships too. So I had a diagram that said my system was supposed to maintain the engine, and then under maintain engine, I had all these activities. Under monitor engine, I had these activities. And so I have my functional decomposition here. And again, I can use this to see what is impacted if something changes. Maybe something changes in here. It's going to have downstream impacts, and it could have upstream impacts. And I can follow these relationships to see what is going to have to change as a result of something in here. I can also see that, you know what, monitor engine was the only one that's been decomposed. What's up with all these other ones that haven't been decomposed yet? Are they having some sort of issue? Do I need to go help them out with something? There might be something going on here to go work. And so all these traceability relationships, they give me insight to what's going on in my system, what's going on with my teams, and then it helps me deal with changes, because things do not stay the same, right? Our customer needs evolve, your needs evolve if you think about the things that you have around you and what you want out of them, and you're going to have to deal with the change. All right. As I worked I started coming up with the systems I would need to do my functions. And so this helped me come up with my product structure. I know I had a system. And then on my diagrams, I'd added the vehicle and I added logistics. And then under vehicle, I added the monitoring system and the propulsion system. And so I could start developing what my product structure looks like. That my car is going to have a monitoring system inside and a propulsion system. As I worked on my other requirements and my other activity diagrams, I'm going to be adding more under here, and I'm going to be adding more under here, and I'm going to build this out over time. And I've also, while I worked, identified my interfaces between the vehicle and the logistics system, and also between the logistics system and the maintainer. And I want you to think for a second what else I might have identified while I went through this process, but I didn't tell you. And also, I want you to think about the third bullet. I have asserted that we have identified the interfaces. And I want you to think about, wait a minute, when did I actually do that? I haven't really talked about interfaces at all here, have I? And yet I'm asserting that we've identified them. And so if I take a look at my activity diagram again, what I'll see is I took data from the vehicle systems and I crossed this line into the logistics system. And so I know that I am sending data from the vehicle system to the logistics system, that's engine status data, in order to accomplish these two activities. And I did it again here, and I did it again here. And so I have identified my interfaces. I've not defined them yet, but I've identified them. I know the source is the vehicle, I know the destination is logistics, and I know that somehow I have to get engine data over here. And so maybe that is the maintainer, the repair shop plugging that device in. Maybe it's Wi-Fi. You know, you pull your car into the repair shop and it just broadcasts that information over, right? So I have to finish defining that interface, but I know I have one there. And then we'll have to negotiate with these two about what that format of the interface looks like. What does engine status data look like? Is it a bunch of good, bad? I've got a list of things, and next to it, good, bad. Is there more information there than that? A lot of you know with your car, it's just like a number, right? But both sides understand what that number means and can go look it up in the tech manual if they need to. And so there's a negotiation here about that format and also the transmission mechanism. If I'm going to say my vehicle is going to use some Wi-Fi to transmit that data, then the logistics system is going to have something in place, their own Wi-Fi system to receive that data. And the same over here. How am I going to get this data from the logistics system to the maintainer? And again, maybe it's a tablet, maybe it's a whiteboard on the wall, maybe it's an electronic board on the wall, maybe there's some lights or something or some numbers, right? And you start figuring out how you're actually going to do that data. And so now I started to identify my interfaces. And like I said before, I have hundreds of these diagrams. And I'm not going to want to go through hundreds of my diagrams to figure out what my interfaces are, am I? This helped me identify them. But then when I actually want to go find out more information about them, I don't want to go through all these diagrams. So I'm going to make another view of my system that shows me what the interfaces are. And so this is just my first iteration of the view off my first activity diagram. But I know I have the vehicle sending that engine status data, and I have the logistics sending the maintenance order, and the maintainer sending the results back. So I have an interface diagram now. And a good modeling tool will flag when these two don't match. If I try to say this one is sending an engine report or engine analysis, and this one is getting engine status data, it'll turn red. And tell me when I click on it that, hey, the two ends don't match. And this could happen because when we were talking earlier about maybe I don't have the logistics system be the one that analyzes the status data. Maybe I put that in the vehicle so it could display on the dashboard. So what if what if the people working on the vehicle team decided that, you know what, it'd be really cool if we did that and displayed it to the dashboard and just sent that information to logistics. But they didn't actually tell logistics people this. They just went off and they did it because this is going to be so cool. Just wait and see. And everybody's going to love it when they see this thing on their dashboard. Well, they'll go through and they'll update their model information to talk about the kind of information they're transmitting and the format of it. And these guys won't. And this will turn red. And so then somebody looking at this diagram go, oh, I have a problem here. We need to work this out and make it match. Either these guys have to put it back or these guys have to update it. But I've got a problem here I know I have to address. And so this diagram gives me a nice summary and a graphical way of the interfaces that I have. And then there's, if I open any of these elements up, there's more information in here that I can see about that information. I get to decide what I want to display or not display. I could put a ton of information on here for my developers. I can hide some things, which I've done here because I think maybe my customer doesn't want to see a diagram cluttered up with loads of stuff. And so there's options in here to hide and show things. I can keep drilling down on the inside of this and show what all the pieces are, or I could focus on one piece and just show what that is. And so using model-based system engineering, I would get a bunch of different views of this. I would get automated checks of this that help me do my work. I want to see how we're doing with defining my system. And at the beginning, I said that my system has structure, and it has behavior, and it has relationships. And so I've got a pretty good start there. Here's my system broken down into vehicle and logistics. The maintainer is something external from the system that I'm building because I don't build people. And these are the functions I've decided each system should do. And these are my relationships that I have across the systems. And so I'm making a pretty good start on defining my system for that one requirement, right? Now I got to go back and do this for all my other requirements and make sure everything lines up. And if you can imagine having hundreds of these diagrams for hundreds of requirements that you have out there, this starts to be a massive amount of information to keep track of. And when I make a change, I don't want to have to go through 300 diagrams and make a change. You saw me spell RPM wrong on that slide, right? Just a little typo there. I spelled it wrong. I don't have to go in and fix that on every diagram it appeared on. Okay, I just need to go in my model in that one place where I typed it in wrong, fix it. And then all the other diagrams are just a view of that modeling data, and it will reflect that change. And so I made a little mistake there. It's not a big deal. I just go into the modeling tool and I fix it, and everybody is going to see that fix. When I use documents and stuff, I got to go find every document out there that has that in the picture and go put that picture in there. And odds are pretty good that I'm not going to find every single one of them, am I? Because these things, they get copied, they get emailed around, they're all over the place. And I'm probably not going to know that Oscar over there made a copy of my document and posted it over here, and now I've got the version where I fixed it, and instead of finding my version where I fixed it, somebody found the other version posted somewhere else, and they're looking at the wrong information. And this might be more serious than a typo, right? I could have just gotten my entire activity diagram wrong and had to go fix it, right? Or I got my requirements wrong, or the customer changed their mind and they wanted a change. And so there's all sorts of reasons why I might have changes. Some of them are good reasons, some of them are bad reasons, but they're out there, and I make a lot of updates to it. And when I use a document, before you know it, I've got a document that has these 2 fixes in it, and this document with those 5 fixes in it, and this one with 10 fixes in it, and none of them match. And so one of the things I like about modeling is that it always matches. right? If you decide this function isn't just good for the vehicle, that there's something else that could use a collect engine status, or I built one kind of car and now I'm going to build another kind of car and reuse that function, I can just use it again. I don't have to define it all over. I don't have to keep track of everything. I just go, here's my model elements. I just kind of drag it over into my diagram and allocate it to a new system, and I get to reuse it. And if the output here changes because somebody changes it, it's going to turn red on my diagram because it doesn't match the other end. And so the model will help me keep track of things. And I've gone through this whole functional analysis stuff where I just I try to put myself in the position of a customer. I try to put myself in the maintainer's shoes and think about what would the maintainer want? What does the customer want? What do I think the vehicle should do? And try to think of a logical flow to go through here. You can do this in text if you want. I could just as easily write a sentence that says the vehicle monitors the engine and produces the engine data. And then the vehicle collects that data, turns it into engine status, and then it stores it, and then it reports it. It's really hard to show things that are happening in parallel in a text document because you just write sentence after sentence. And you should wait for the jet to finish flying over my head. That's probably an F-35. And so I could write this out. And some people like that, and because it's nice and easy to read, and I like it too. But if I wanted to, I could run a report on this because all those words are here, and I could generate that for the people that wanted to read it in text. But what this graphic helps me do is I can also see if I have any deadlocks. I can see if something over here is waiting for data from over here, while this thing is waiting to receive data from over here, right? I could check the flow. Does it make sense to me? Does it make sense to my customer? Does it make sense to people who are going to define the vehicle, right? Does this flow make sense to you all? What if I left out a step? It's a lot harder to see in a text document for me. And what if, you know what, this kind of just stopped here. What's up with that? You know, is something supposed to happen after this? Was it supposed to stop there? There's actually a symbol I can add that makes it explicit that I wanted to stop here, right? And I didn't add it, which when I see something like this, it makes me wonder, did they not finish this diagram? Is there something more that was supposed to happen here? And so it's a quick and easy way for me to check. At the same time, I know we're all different. We have different ways of processing information, and there are people out there that would prefer to see the paragraph of what's supposed to happen and read it, and that could be auto-generated from this using the tools. It can get this information and it can follow these flows, and it could spit that out for people that prefer to read it that way. You can kind of have the best of both worlds here and make a number of different stakeholders happy with seeing the data in different ways. I have people that like to see the activity diagram. I have people that hate activity diagrams and they'd rather see the interface diagram that I showed you a while back. And I have people that they don't want to see this. They want to see a table. Well, I can generate a table from this. The table just follows these relationships and says, oh, this is what's on this end, this is what's on that end, and this is what's in the middle, and it makes a nice little table. And I can generate a list of my interface control data from the model and say, okay, this is what everybody is sending to everybody else. You want to review that for me, Satya, and say, hey, yeah, that's good. That's what I think should happen here. Or go, no, I'm the vehicle system. I'm not sending that data to you. No, right? And so I get a bunch of different views of this. And that's one of the things I like about modeling, along with that, I only have to fix it in one place and it updates everywhere. And also I can do that traceability analysis because things don't stay the same. There's always things that are changing. There's always things that, mistakes happen, they have to get fixed, right? And one of the things I wanted to also show you is my design there, it's not perfect, is it? Did it have to be perfect to be useful? Right? There's information in there about what my system has to do. The problems are in there too, because problems exist, right? And I want to keep track of those. I want to be able to find them, and I want to get solutions to those problems. And excuse me, well, I don't know what all the data is. I do know I need something there, and I could put a placeholder there, and we can work on solving it. If I don't do that, people might forget about it. It's not in your face. And a lot of times, those of you that have taken the System Engineering Bootcamp class that we've taught at UTEP, a lot of times we have you do some work, and some of you have gone through this, and we said, okay, the customer's here. You guys have any questions for them? And what we see is people going, and this happens at work too, not just in class with the students, right? You see people go, I don't remember, right? Well, I've maintained a list of them as I go. And so when those opportunities come up, I can ask them. And so what I've done here with my model is I have taken one customer requirement that was not so good. It was not written at the system level like we tell everybody to do, right? And the customers, they're not going to listen to you and stick at the top level just because you told them to. There are things that they want, and they don't care if it was at the top level or down in the detail. They know they want it. They're not going to follow that rule. And so we've taken that one requirement, and we came up with one system requirement, a bunch of stuff that's going to have to go in a statement of work for my company to do, a whole bunch of subsystem requirements, a whole bunch of functions. We started the system structure, but we haven't finished it yet, because as we work on other requirements, we're going to fill that out. And we've identified our interfaces. And we've taken this top-down iterative approach, right? I've worked on one requirement, and I did some stuff. Now I'm going to go on to the next requirement, and I'm going to do some stuff, right? It's not parallel. I don't do all my requirements and then do all my activity diagrams, and then do all of my system structure. I work on a piece of it, and I go back and I work on the next piece, and it's kind of this zigzag thing that's going back and forth. And as I work on this activity diagram, maybe I realize I left something off the previous one that I worked on because I figured out something new I didn't know before, and I go back and I work on that for a while. And I keep doing that until I fill out my system architecture. Meanwhile, my software engineers are going to have to go write code for this. They don't have to wait for me to have the entire system architecture done yet, do they? I know I need a function to monitor that engine, and I know I need to collect the temperature and the RPM, and I'm going to have to compile that data. Is that enough information for somebody to start writing some code? Even though I still don't know what mission systems is supposed to be doing? I don't even know what mission systems is yet. Somebody just kind of threw that in there. But I do know a couple of things about what the vehicle system is supposed to do. And so some people could start working on that while I go figure out what is that mission systems thing that somebody threw in there. And so I hope this approach helped you guys. Just trying to take, this is something that's really happened at work. It doesn't quite align with the academics of how we teach you do system engineering. We teach you to write a requirement, and it's perfect, and you do an architecture, and it's perfect. It doesn't work out that way, right? We do have to go back and fill in the gaps and figure out what's wrong and do analysis and keep going. And so I wanted to give you guys a practical example. And I wanted to show you how to use the model-based system engineering approach to go about helping me with this. So if you all have any questions, let me know.
Thank you, Yvonne, for the wonderful presentation. And I think your stress on the point that the whole adoption towards model-based systems engineering helps us to translate all the artifacts automatically, right? From the whole document-centric to the model-centric approach, right? I think it's very great. And then I have a question, but then before I'll open the floor for a couple of questions. Participants, if you guys have any questions, please feel free to unmute yourself and then ask questions. Thank you.
You can type them in the chat window too if you prefer to type them. I've got that open and I'm monitoring it.
Yes, please, you could do that as well. Please go ahead and then type in your questions in the chat window and we are monitoring.
I have a question.
Okay.
Okay, so how do you present those diagrams to your customers? Because many of them are not technical customers. So do you scare them, or what's your approach so you will be able to validate your understanding?
Most of the time, we are writing reports to pull those diagrams out of the tool into a Word document, right? That they could just read from top to bottom and follow along. And instead of knowing that they have to open up the specification for this object and then open up the specification for that object, we write a report, we have the diagram on there, and then underneath that diagram, there's a description of it and the pertinent information that they need so that they don't have to navigate their way through the tool. And then we try to keep the diagram simple. So while I was using SysML here, do you need to know SysML to read this diagram? And what I have done on some of these diagrams, by the way, is I don't know how familiar some of you are with the tool I was using here, but I have modified the symbol properties to turn off some things. I'm not displaying everything because I don't want to overwhelm the people looking at this diagram. And so for here, I wanted people to be able to see the flow here and what the interfaces are. I turned everything else off. Right, and so it's not cluttered, and it's important when you think about your customer who may not know how to use the tool or read these documents, to think about what they're going to want to see and set the diagram up to that purpose. Turn the things on and off, right? Don't leave every single option here on just because you can, right? There's a lot more things I could show on here, and I didn't do it because it's overwhelming. And so that's one of the things that we're doing. We do have some customers that are actually in the tool with us looking at the data. And so we're making navigation aids, not just for our customer, but internally for people. Looking at somebody else's model, by the way, is hard. The way they organized it is not necessarily the way you would have organized it. And so when you open up a model, you don't know where to go. You don't know where to look for things. And so we're setting out kind of navigation aids, which are really just a bunch of links to say, go look here, then go look here, then go look here. And so we're basically still generating Word documents for our customers, Oscar. And we're giving them the diagram and all the description. So basically a report of everything that we put in the tool, but ordered in a way we think makes sense for them.
Personally, I think that the diagrams is the best way to present the information to the customers. And I'm in favor of the diagrams. I was just curious on the approach on how to explain the technical aspects of the models before we go into the models. You know,
Right.
so like not to scare them, but to bring them into loving the model.
Okay. Part of it is about filling in the metadata, right? And you don't want to quite scare your customers with that one, but you want to scare your engineers with it. It's not enough for me to name these things, is it? Do you know what I meant by vehicle? Did you know what I meant by logistics when I put it up here? All of these have a field for you to populate the description, and so that's a good place to start. This diagram should have a description about why I produced it and what its purpose is for, right? And this purpose is just to give you a high-level view of the data going from one system to another. That's it. I turned all the other things off so they don't show up on the diagram. And filling out that kind of information, that's not very difficult. It shouldn't scare too many people away. And so they don't. So your customer doesn't have to worry about the mechanics of the modeling and stuff. If you generate a report that shows those description data to help them understand what they're looking at. And then when you come back and you look at some of these, you might need to put in the description field something in here about how to interpret this, right? That, oh, this is for showing me how to go from my requirement to the child requirement to the system to the function, right? And then I think if you just, that was just one sentence, right? And I think if you give that to them in the description in a report or on the diagram when they're looking at a diagram, it'll help them know how to interpret this.
Thank you.
Go ahead. Jaime, do you have a question?
Yes, Dr. Bijan, thank you for the great presentation. My name is Jaime Paz. I graduated from UTRGV with a bachelor's in manufacturing back in May. I have a question about your model.
Okay.
When an activity element involves the interaction of two entities, such as the mechanic and the customer, whose side do you prioritize in the model?
So you have an activity that the maintainer is partially responsible for and the customer is partially responsible for. Is that okay? So let me make sure I understand that. I would not give it to either one of them. Okay, there's another level above that the two of them have in common, and it goes under there. So what do the maintainer and the customer have in common? They're probably both stakeholders, right? And so that function that spans two of these swim lanes doesn't go in either one, because that makes it ambiguous about who's responsible for what. So whenever you have a function that you think you want to put right here on the line and say this one's responsible for part of it, it really goes in the next level up. And then you have to decompose it and say what exactly it is that the maintainer is supposed to do and what exactly it is the customer is supposed to do. So when you have a function like that, you need to decompose it and then put the pieces in the proper swim lane. Does that make sense?
Okay. So basically, do you just, I guess my question was, do we design for the worst or the best case scenario?
A lot of times it's the worst, because the bad situations that you deal with, they're usually the stressful ones that are driving your system to have to be more rigorous or harden or more reliable, right? The best situation, that's usually easy to do, right? For my car, do I want to design my car to only be able to drive on well-paved roads? Or do I want my car to also be able to go on those roads with all those potholes on there? Do I want it to be able to go on dirt roads and stuff? And if I was somebody that wanted to use dirt roads, maybe that's my worst case situation. You don't want to design for the fact that 90% of the time I'm going to have my car on a paved road, because then I'm never going to be able to take it out on a dirt road like I like. So it's going to be the worst case. Another example is we have oil rigs under the ocean, right? And they're designed to, drill in the oil and store it, right? And so that's great, but pressure can build up in the pipes. And if you don't think about that worst case scenario of when pressure can build up in the pipes, you might end up with an explosion. And so you need to design some way of relieving that pressure. And so I think normally you end up designing to the worst case scenario that you have to deal with.
Oh, okay. Thank you.
Any other questions?
I had a quick question.
Okay.
Maybe I'm getting too far in the weeds, but when I think about corrective action, I also think about a corrective action that's materially supportable. We know what we need to do, but we don't have a part on the shelf. Is there another line that we need in there, or is that just something beyond what we're doing here?
Okay, so when you think of a corrective action, what do you normally think about?
Part plus the person who turns the wrench. If we don't have the part, we need to replace.
Gary, I can't hear all that. You're breaking up a little bit. Could you type your question in, maybe?
Material support parts.
Okay, so there are different kinds of corrective action, and maybe my language here is too vague, right? And so if the corrective actions are all handled the same way, it's fine for me to use this terminology and reuse that function in other places. And so I could use it for the materials and parts and stuff too. If that's not the case, then this means that my language is ambiguous and I would need to change it to be more specific about what I meant. And so maybe I shouldn't use corrective action here at all. Maybe it should be maintenance action or something, right? And so when questions about that come up, like, well, did you mean this or did you mean that? If the way I have to handle it is different, it means I need to fix the language that I used. Does that answer your question?
Yes, it does.
Thank you, Gary. And Yvonne, I think you already answered my question, piggybacking to Oscar's, what Oscar was talking about. So my main concern was how familiar does the customer need to be in terms of the tools and the languages we use for implementing model-based systems engineering?
That depends on the customer. We have some customers, they want our deliverables to be documents back to them. And for them, I don't think they need to be familiar with the tool at all. We're going to generate a report from the tool with the appropriate information in there. But we have other customers that they want to do the reviews in the tool. They don't want to look at a report. They want to see everything that we have in the model. I think they want to make sure that, like, we didn't leave something out or we actually did put it in the model. Those customers, they're going to need to be familiar with the tool and the language and the methodology that we used. And we do have some of those customers, and they're sending their people to training to get that familiarity. And then we have another level of customer that wants more collaboration between the customer and the contractor, and they actually want to be in the tool modeling with us and reviewing it, making comments, making fixes, and they're going to have a more advanced level of being in the tool. Maybe they want to make their own views of the data and stuff that suit their purposes. And so we've got this level where they don't need to know anything if they just want their documents. To this level, they have to be able to navigate through the model and know what to look for and where to look. To an advanced level, they actually have to be able to create the elements and the views that they want themselves. And so it's highly dependent on the customer that we have.
Thank you very much for that.
And it's something we're all struggling with. It takes a long time to learn these tools and then acquire that level of knowledge. And the contractors and the customer are both struggling with this.
Mm-hmm. And talking about the tools, do you think, do you guys use just one tool all the way throughout the whole, what do you call, modeling, or is it that you switch back between the tools in terms of the familiarity with the customer?
We have different programs using different tools, depending on what the best tool was at the time a program got started on, or depending on what the customer said that they wanted. And so as a company, we're using a couple of different tools across programs. The system architecture, we are encouraging everybody to pick one tool for their program, right? As a whole, you should be on the same tool, but we haven't achieved that everywhere either. And this causes integration problems because none of the tools really talk to each other very well. Some of you might have experienced that on your projects and stuff. If you wanted to use different tools, they're not really interchangeable. And so we do like to see that everybody on one program use the same tool so that you don't have the transcription errors of going from one tool to the other. Every time we export out of one and import into another, we lose some stuff, and you have to go add it back in manually, or you have to go clean up the diagrams, and it's a lot of work, and it's manual work right now. And you know there are committees out there in COSI and the Object Management Group. They have committees that are working on tool interoperability, but we're not there yet. So to answer your question, we have a lot of different tools. It's a problem. and we don't really have a good solution for it. Sodius and other vendors are working on integrating the different tools, and so there's some capability there, but generally we want more integration capability there.
Okay. Thank you. Let me check the chat window to see if we have any.
Yeah, we have a question from Sergio. So Sergio, you asked me, how do I know when I can stop decomposing my model? And basically, that answer varies a little bit based on the program. And I stop decomposing my system hierarchy when I reach a make-buy decision level. And so I'll use Lockheed Martin F-35 as an example here. F-35, Lockheed Martin does not build the engine that goes on Lockheed Martin, that goes on the F-35. It's contracted out. And so I, as a Lockheed Martin employee, would not decompose the engine at all on F-35. Another company builds that engine, and they're just going to give it to me, and I stop there, all right? But there are other parts of my system that we build ourselves, right? And so I'm going to keep decomposing that till I get to a point where the hardware engineers and the software engineers say they have enough information to go and build what I need. Does that help?
Yes, thank you, Dr. Bijan. Appreciate it.
Okay.
It looks like we have no more questions. So in that case, thank you, Dr. Bijan. Thank you very much for your time today. We all really appreciate your insight provided. All right, guys. So for the next agenda, we have the workshop convening at 1 o'clock. So we have a brief lunch break from now until 1 p.m. Central Time. So if I could, let me share my screen real quick.
Thank you, Dr. Bijan, for your talk. Thank you very
Thank
much.
you for having me. I thought this was a lot of fun to do.
Thank you. Thank you very much.
Thank you.